This is kind of a summary of what we just did. We'll do a couple practice in just a moment. Here's a summary of what I was talking about on page bottom of 107. So just by counting the groups, you can know what exists. So groups are key. Now if I flip to page 95, which I've referred to a couple times, and it's posted online, this is pretty much a summary of the last two chapters minus MO theory. So just to kind of, all this comes from Lewis. You should be able to draw the Lewis structure, and then counting groups tells you everything. Counting groups tells you the bond order. It'll tell you the shape, both electronic and molecular. And then the shape tells you the bond angle. The shape also tells you the polarity. And then what we did in this chapter, it tells you about the hybridization. So once you count groups, you know hybridization. Whatever you want, Frank. Yeah. I had one that I gave to Corey, but that's all I have. So.
You want me to hand them out?
Yeah, I have to keep going.
Okay.
Yeah, they want to hear about the finals. No, I cannot. You know what I mean?
Yeah.
I cannot. No, I just made a major flub, so these are gonna go down in score. But anyways. You have to count the groups to get the hybrid. We didn't really do much of this down here, besides this basically has to do with tell me what hybrid orbitals overlap to make a bond. Okay? So minus MO theory, this is the summary of everything, and as you can see, it's all based on Lewis. So if there's anything you're going to practice a lot, it's Lewis structures. In the reader and also in the text, you'll see, I want to point out this too. So I got similar practice examples on page 109 as what we did just now. On page 110 and following, we're not specifically going to go over this material from section 6 and following. So you can read it for fun. One thing I'll say that will help your homework though, whenever there's resonance, that's called delocalized or delocalization. So you might need that to do your homework, and that's page 110. But otherwise, this will become more of a big deal in Chem 2B and C. Chem 2B and C and everything else, that's going to be a big deal. Okay, that's page 110 of the reader, delocalization. All right. Now, I guess since I'm holding the reader, let me just finish. This out of the way. On the last page, page 112 of the reader, I made a list for you. People often ask me, what should I know for Chem 2B? There's it. That's it. What you should know for B and C. So if you wanted to know what you should know for upcoming classes, these are the most significant things to know. If there's more algebra in 2B, you're going to do a quadratic equation and things like that, and a lot more with logarithms. It depends who you take a little bit. Okay, and then I have my office hours, just like before, I have all my YouTube, and a couple people have asked me, so I will put it in the books, the Davis Copy Max. My 2B readers are yellow, because yellow is the color of 2B. Red is the color of 2A, that's red. But I'll put this, if people want it, you can use it, that's fine. But I won't be teaching the class, so. Yeah. Oh! For 2C, I have my lecture on YouTube. So I have videotaped my lectures. And for OChem, I have some stuff. OChem and other advanced classes, I do have some playlists, just to let you know ahead of time. So if you ever need to refer or need stuff all the way through OChem, it's cool. All right. Hey, person. Yes. Sorry, that would have taken me down in points too. Yes. Spring quarter is a question. I'm not sure. I don't get scheduled until about the time that you all, when the courses get listed. I would guess 2B. I would guess, but I can't know that for certain until this close. But that has been my pattern the last 4 years. I've been scheduled for 2 years. Okay. Enough of that. That's depressing. Okay. I want to do a couple different kinds of examples. Just try this molecule here. Try the Lewis and kind of figure out everything about it. So 3 bromines in column 7 plus 1 electron, that's 22. Just wanted to do an extra one where you can see a full problem. Here'd be a full kind of problem for just a random molecule. Okay, for a full problem, again, just like before, you all start with the Lewis structure first. Draw the bonds for the skeleton, 2, 4 of 22. So 4 electrons of 22, then you go on the outside. 6, 8, 10, 12, 14, 16, 18, 20. And now in this case, I still have more electrons, but everything has an octet. I'm going to exceed the octet on first any element below the carbon row, which all 3 bromines fulfill, and my first pick is always the centermost atom, or a center atom. So any center atom, I would exceed the octet on first before the outermost terminal atom. Okay, and then you put brackets. Next thing you do is formal charge. What's the formal charge right there? Yeah, it should be 0. Bromines in column 7, and there are 1, 2, 3, 4, 5, 6, 7. So that's 0, same with the one on the left. But this one would be minus 1. Again, it's in column 7, but you count 1, 2, 3, 4, 5, 6, 7, 8. So here's where the minus 1 comes from. Remember, the sum of the formal charges equal the overall charge of the molecule. What is the sum of the oxidation states equal, by the way? Also the overall charge. Doesn't matter which one you use. The formal charge is based on covalence, and the oxidation state is based on ionic type bonding. Okay, so now we got that. Kind of simple for this question, but let's do the sigma and pi's. How many sigmas? Just 2. Okay, 1, 2. Guess good, we did it. And 0 for pi. No pi bonds. Okay, we'd also do the hybridization for this atom. What is it? Yeah, there's 5 groups of sp3d, or dsp3. Okay, we also do the shape. So what's the electronic geometry? For 5 groups, trigonal, bipyramidal. Okay, the molecular geometry would be, linear, because 3 are lone pairs. So thus the bond angle, 180. Okay, did I miss anything on that page? Let me just double check that I didn't miss anything that we could try. Bond order, that would be a simple question, be 1 for each bond. Oh, polarity. Yeah, just considering this entity by itself with no counter ion, you just consider this entity by itself, this would be just considering this entity. Now, if it said something like, sodium Br3, then this would be polar because it's got that sodium. All right. So that would be kind of a sample of an entire problem. Yeah.
Can you give us a question with more
Yeah, if there's one with multiple angles. So for example, PCl5, this would be a trigonal bipyramidal if you drew out the Lewis structure. And in that case, you should be reporting 90 and 120. Some people additionally report 180, but I don't personally require that one. So you should, in this kind of trigonal bipyramidal, you need to report all angles. Yeah. All minimum angles. Like, you don't need to write 360 or 270. Then for the same reason, you don't have to put 180, but you can if you want.